You're welcome to my YouTube channel. In today's video, we'll be looking at a brief introduction to exponential functions. And so, as to brief introduction, we will look at what exponential functions are, and then we'll try to start from the basis with some examples in exponential functions, then we'll go to some more complex problems. So, what are exponential functions? Exponential functions are functions in which the functions are raised to powers that are unknown. Yes, so exponential functions are functions in which the functions are raised to powers or index that are unknown. For example, we have exponential functions like, say, 2 raised to the power of x equal to 8. This is an exponential function because the power is raised to a number or to a function, or is raised to a number that is unknown or a term that is unknown. So in this case, it's not like in deco functions where you have the number raised to a number or a function raised to a number. In this case, we have that the function is raised to a power or an index that is unknown. So in this case, how do we find the unknown value in such a function when we have functions like this in maths? How do we find it? They are very, very simple. So first, we are going to look at an example. Let's say we have 3 raised to the power of x is equal to 9. Now, for example, we have a function like this. So when you have a function like this, how do you treat it? When you have a function like 3x raised to the power of 9. So 3 raised to the power of x is equal to 9. How do you treat it? Now, the first thing you are going to do is you have the two sides, the left hand side and the right hand side. Now, what you are going to do is that the lowest base, the lowest number here, which is 3, what you need to do is you make this other number that is on the right hand side to be on equal base with the one on the left hand side. In that way, you'll be able to do what? To terminate the bases. For example, 9 can be expressed in base 3. So that means that we can say 3 raised to the power of x is equal to 3 raised to the power of 2. So in this case now, we can balance the bases or cancel them out by saying that our x is equal to what? 2. And so if you check if the function is right, or if the unknown value, which is 2, is right, you substitute 2 into a function. For example, they said 3 raised to the power of 2. The answer is what? Is 9, because 3 times 3 is what? Is 9. So that is how you solve a mathematical function. Now let's look at another example. This is example 1. Let's look at example 2. Now, but in this case, you have the unknown value as the base. You have the unknown value as the base, and then you have a number as the power or the index. In this case, how do you find it? And it is equal to what? Let's say 3. Equal to 3. We have x raised to the power of 1 over 3 is equal to 3. So how do you find it? In this case, it is very difficult to express the base or to express this unknown in the same base with the number on the right hand side. So when you have a problem like this, what are you expected to do? What do you do then? What you do then is that you play with the base, the index mathematically. Now what we are going to do here is that we are going to apply a law in indices, and that is the power law, that says that when you have a base, when you have a power, and then you multiply it, that it is possible to multiply it with another power. So that means that in this case now, remember this is 1 over 3. And so if I have 1 over 3 and I multiply this with 3, that means automatically I have 1 here. But remember, in equation, whatever thing you do to the right hand side, you also do to the what? To the left hand side. So in essence, you are going to multiply this power with 3, and then also multiply this the power of this one with 3. And we all know that the power of 3 is what? Is 1. So in essence, we say multiply the powers with 3. That means you're taking the same effect with the left hand side and also the right hand side. So in that case, you say multiply the powers of the bases with 3. And so first we say x is equal to, or x raised to the power of 1 over 3 into 3. Then is equal to 3. Then here is 1 into what? 3. Can you see that? So now, in this case, we now have that x is equal to 1 over 3 times 3, with what we did. That means 3 will cancel out this 3, and what we have here is what? Is 1, which is the same thing as what? As x. Then here is now equal to 3 raised to the power of what? 1 times 3 is what? Is 3. And so our x is equal to what? 27. So that is a brief, that is how you tackle situations like this. So let's check if our answer is correct, that x is equal to what? 27. Now let's substitute. Let's quickly check. Now you say x is 27, so say 27 is the power of 1 over 3. Now do you remember this law? If we have to tackle such a problem, in indices they call it the root law. And here we have the fractional index. And so in this case now, we take the root of the denominator and raise it to the power of the numerator. And this is 3. That means we take the cube root of what? 27, all raised to the power of what? 1. So in this case now, what is that number that multiplies itself 3 times to give us what? 27. And we know that we have what? 3 times 3 times 3. That will give us 27. So that means the cube root of 27 is 3. And so that is why we have our answer to be 3. So that is a common way of solving exponential functions. Functions in which the power or the index is an unknown number. So click on to the next video where we are going to solve a more complex problem in exponential functions like this. Thank you.